Good afternoon, good evening, anyone watching this video. Today I'm talking about indices. You can see from the whiteboard that we have numbers with its index at the top of it. When I talk about index, when a number is given and it has an upper one, that is the index of the number, or the exponent, or you can also call it the power. This is the same thing as saying a raised to the power n. Now that is for indices. Now a situation is given to us on a board and it asks us to simplify and solve for y. Now in this kind of situation, what are we going to do? We'll look at the base of the both numbers. The base, the first one is in 3 and the second one is 9. Now this 9 is a perfect square. When I talk about the perfect square, I mean a perfect square is a number that can multiply itself to give you another number. Like for instance, we have 2 multiplied by 2 to give you 4. This 4 is a perfect square of 2. Same goes to 9. 9 is a perfect square of 3. 1 times 1 is a perfect square of 1. 4 times 4 is a perfect square of 16, and so on and so forth. Now, going back to what we have here, we can make this a perfect square. Making this a perfect square, this becomes 3 raised to the power 2, because 3 raised to the power 2 is the same as 3 times 2 equals 9. So this is saying 3 raised to y plus 3 equals to 2 bracket 3. Now, why is it like this? It is like this because 9 raised to the power 3 is the same as 9 times 9 times 9. Whereby 3 raised to the power 2 bracket 3 is the same as 3 raised to the power 2 times 3. That is the second law of indices. When you have two exponents multiplying themselves, it's like this to give us 3 raised to the power 6, which is the same as 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, and 6. Now, when you solve this, you're going to arrive at the same answer for the both of them. So that is just the same thing. Now, we've broken this down to this level or to this page. Now, what do we do next? We have 3y plus 3 equal to 3. Now, 2 times 3 will give us 6 equal to 3 raised to the power 6. Now, we can see that we simply simplify it to get the same base. The same base. And now, when we have the same base with an equal sign at the middle, we simply take off the base. Now, we now have the exponent. So, we break down the exponent. 3y plus 3 is equal to 6. Now, we have gotten to what we call the linear equation, or algebraic expression. Now we've gotten to this stage. Either you call it the linear equation or you can call it the algebraic expression. Now what do we do next? We know there's what we call collecting of like terms, or you can call it grouping of like terms. What do we mean by collecting of like terms? When we say collecting of like terms, we mean taking all the numbers with a variable. When I say variable, I mean a letter. Variable can also be called what? A letter. When I mean letter, we know letter means an alphabet. So we can take all the families of the numbers with a letter to one side and the ones without any letter to the other side. That's what we mean by collecting of like terms. Now, with this equation, to collect the like terms here, we have 3y will be equal to, now this plus 3 will go and meet the 6. Now, when a positive sign is crossing an equal sign, it changes to negative. That is to say 6. Now, this is a plus sign. When it crosses this equal sign, it becomes minus. Then the number goes with it to become minus 3. Now, when I have 3y will be equal to 6 minus 3 to give us 3. Now, there is what we call dividing both sides by the coefficient of y.
what I mean by the coefficient means the number attached to the what? To the letter. That is the coefficient of the letter. The number attached to the what? To the letter. Now this y is a letter and this 3 is the coefficient of y because it's attached to what? To the y. So we divide both sides by what? 3. So therefore y is equal to 3 here, 1, 3 here, 1. So y is equal to what? 1. This is our answer.